Let us tell you about John, who works in Chengdu, China. He is working in one of the tallest skyscrapers in the city. As a technology geek, he is catching every gadget, especially when it can help him. That is why he chose to download Help just in case. After all, he lives in dangerous seismic area. It is Monday, May 12, 2008, after meeting John drives home to rest, when suddenly a terrifying noise and vibrations wake him up. John woken up by the beeping sound. He is lying in a pile of gravel, surrounded by the debris of his building. Is this the end? He thinks. Hopefully no. His smartphone iteratively starts to activate and perform some questionnaires asking about John's health and the surroundings. He is saved. Mary often travels as a reporter to many distant locations, one of which is Japan. She is a very cautious person and often listens to news reports concerning natural disasters and most of all earthquakes reports. Unfortunately, Japan is one of major areas where seismic activity is at highest levels. Mary worries a lot about the travel, so she tries to find out as much as she can. When she stumbles upon help applications using her smartphone, she discovers powerful tool which senses the threat situations, but most of all disseminates the real-time data accessed from open seismic reports. Using Help application, Mary finally has a tool which offers her a useful handheld application, accessible everywhere and at any time. No earthquake threat will surprise her again, making her trip more safe and enjoyable. Problem definition. One of the major natural disasters are earthquakes, which until this time humanity cannot deal with. It is considered to be the most frightening and destructive phenomena of nature. The earthquake is so dangerous that we cannot stop it and cannot fight with it effectively. It is impossible to predict with precise date and time, where will the next big earthquake strike. Of course, there are regions in the world where earthquake occurs more frequently, but according to latest statistics, new areas of land are covered by this problem, and every year it comes to about 2,000 earthquakes, including more than 20 strong shocks, with the number of victims given in thousands. Moreover, Earth's seismic activity in recent years is increasing. According to a study, every year thousands of people are killed and hundreds of thousands are injured. In total, over the last 60 years, earthquakes took 1.4 million lives. The earthquakes are the source of overwhelming losses. Usually, overall cost of the earthquake is given in thousands of millions. The result of the earthquakes are most destruction and damage to buildings and land subsidence. Helping people affected by this disaster is particularly difficult because of limited access, limited emergency power and the absence of any information about the location of victims. First hours after accident are the most important in rescue process. It is a short period when the victims still have oxygen resources and any medical assistance can help them, but the victims are usually found too late. The localization in big debris is the major problem for effective help action. We want to change it, using the well-known personal device, smartphone and our system. Nowadays, smartphones are easily accessible and popular in each region of the world. That gives us an opportunity to spread our program over the world for each necessities. Our system can be also used in other ways. We have researched different patterns of falls, so we are able to detect building collapses, landslides, avalanches, falls and fainting, hurricanes and of course earthquakes. Solution and innovation. Introducing the innovative crisis management code name HELP, which stands for Handheld Earthquake Life Package. Our system helps people affected with natural disasters by identifying and monitoring their medical state and location. Help is the first mobile system that offers comprehensive assistance to victims of earthquakes. The application uses the built-in inertial sensor devices to detect common crisis threats, collapses, landslides, falls and fainting. Help application transforms your ordinary smartphone into life-saving device in case of earthquake or any other landslide. Help automates the detection of potential earthquakes by analyzing the vibrations of the body, volume and brightness of the environment. Apart from the smartphone, our system can run on programmable watches equipped with the required sensors. In addition to GPS and GSM, we decided to use a Wi-Fi signal that periodically transmitted serves as a marker leading rescuers to the victim. Help is using our RFID and NFC and personal database to identify the person and his medical profile to help improve medical services. Software innovation involves the use of all available technology in the device to the location and diagnosis of victims were held in an automated way, even when a victim lost consciousness.
Can you hear me? Tap the screen. Thank you. Can you move? Tap the screen. Thank you. Can you walk? Tap the screen. Thank you.
The system recognizes the user's status by analyzing its interaction with the device and the environment, ambient brightness, sound, and provide timely information to emergency services.
Be careful.
These few simple steps, which will perform a smartphone without the need for user intervention, will significantly reduce the time it takes to find a man in a collapsed building, reduce wait time for emergency services, and thus help to save human lives. Architecture and technology. We have based our application on multi-tier enterprise architecture. It delivers a scalable architecture, which has been tuned according to Windows Azure guidelines. The main and the most innovative part of our solution is a set of mobile applications for Windows Phone 7, 8 and Android smartphones. Mobile applications consist of views and a background service pool, which is responsible for sensor data fusion and communication with help server services. Windows Phone platform, due to security reasons, restrict continuous sensor monitoring, therefore help implements delayed sensor pulling algorithm. Mobile application contains a set of heuristic algorithms for sensor data fusion, recognizing continuous vibrations of the device in loud environment. All of the device annotated with other information from proximity and light sensors. The communication subsystem is responsible for reporting status to server and other devices in case of emergency, with additional text-to-speech service support. When possible threat is detected, the application signals it by periodically sending messages and establishing Wi-Fi access point in order to simplify the localization of injured. We have successfully applied MVC pattern and its extension MVVM in form of Silverlight web application. The business logic tier have been developed choosing WCF-based services in addition to infrastructure of available web map services. Create a SO-based solution. We concentrated on Microsoft technology stack as it has improved team productivity especially, while developing rich internet application solution. Web portal offers basic functionalities aimed at visualization of reported threats. We will extend its functionality to deliver geofencing capabilities, which will enable subscription of events occurring in the defined area. At this time, the system has been deployed on the university's resources for locally hosted experiments. Moreover, we already started migration process to Azure cloud environment. Our system integrates also external communication channels such as social media portals, Facebook, Google+, Twitter. We have considered such media as significant for rapid information spreading. Research in field of social networks proves that such evolving structures increase the efficiency of social communication, therefore improve processes of assistance and rescue. Our technology consists of selected combination of complementary data fusion algorithms. Our research shows that combination of selected signals and special questionnaire-like dialogue between application and user can diagnose the injury or a health state.
Thank you. Do you need help? If not, tap the screen.
We have experimented with wireless heart rate sensors as additional source of information for user diagnostic. However, we want to keep the application simple, autonomous. That is why we minimize usage of external sensors. Business viability. We have reviewed statistical data to estimate our market capacity. Analysis shows that we can rely on almost 98 million instances of our application. This can ensure complete return on investment in the first 10 months of product availability. Revenue rates have been calculated based on the current application trends. Our strategy relies on 3 strategies. The first strategy involves pre-installation of the app in all locations endangered by earthquakes, estimation at level 43%. Second strategy assumes delivery of a free app and advertisement placement. This will generate almost 32% of income. The third channel of income is based on the specific life insurance policy, which comes with our app. In that strategy, user gains bundle of services, increasing the positioning accuracy of the smartphone and user itself. Estimated income 25%.